So here's a big question for you. Can an AI actually plan a project? And I don't mean just spitting out a list of steps. I mean, really figuring out the smartest, most efficient way to get something done, like a person would? Well, that's exactly what we're going to dig into today. And believe me, the answer is way more complicated and honestly more fascinating than you'd think. We're going to put AI to the test with a calzone.
Right, making calzones. You and I know that you can preheat the oven while you're rolling out the dough. It's common sense, right? You do things in parallel to save time. But an AI might just try to do everything one step at a time, which would take forever. Or worse, it might get confused and try to do everything at once, which is just impossible. The most efficient path, the human way, is all about finding that perfect balance between what has to happen in order and what can happen at the same time. And that right there, that's the puzzle.
And this isn't just some random thought experiment. Researchers actually gave this puzzle a name, the calzone planning problem. Sounds kind of delicious, but it's actually the perfect test for a massive challenge in the world of AI. Okay, so the fancy term for what we're really talking about is asynchronous planning. It's all about the skill of scheduling. It's about looking at a bunch of tasks and figuring out, okay, which ones absolutely depend on each other and have to be done in a strict sequence, and which ones can I do at the same time to save a few precious minutes. This isn't just about a to-do list. It's about optimizing that list for the real world. So this brings us to the moment of truth. Can the biggest and baddest AI models out there today, like GPT-4, actually solve this thing? Can they think like a project manager? Or even just like someone trying to get dinner on the table without wasting the whole evening? So, researchers put them through their paces. They gave them thousands of these planning problems, everything from cooking to writing code. And the initial results, well, let's just say they were not what anyone was hoping for. Yeah, the results were not great. Take a look at this chart. Accuracy is that vertical axis, so you want your line to be as high as possible. And see how almost all those lines are just clustered way down at the bottom? We're talking accuracy well below 50%. Out of the box, with no special instructions, they were basically just guessing. So why did they bomb the test so badly? Well, it turns out the models see a list of instructions as just that, a simple, flat list of text. They don't have that intuitive grasp of how the steps are all connected, which step makes the next one possible.
And this fundamental misunderstanding really comes down to a core conflict. The AI just doesn't see the world or the problem in the same way we do.
This really hits the nail on the head. Our human brains, we automatically see a plan as this complex web, this network of dependencies. We just know you can't pinch the calzone dough shut before you put the filling in. But a standard large language model, it just sees a straight line of text. Every single one of those relationships has to be explicitly spelled out for it. And that's exactly where the whole plan just falls apart. But here's where this story gets really, really cool. Faced with this pretty spectacular failure, the researchers tried a brilliant new approach. They realized the problem might not be what they were asking, but how they were asking it. They came up with this new technique called Plan Like a Graph, or PLAG for short, and the name really says it all. They decided to tell the AI, hey, stop thinking in straight lines. Start thinking in networks, in graphs, just like a person does. And this visual just illustrates the difference perfectly. On the left, that's the old way. Here are the steps, give me the answer. But on the right, that's the PLAG prompt. And it says, whoa, hold on. Before you even try to answer, I want you to first build a graph of all the steps and show me how they're all connected. Then, and only then, you can use that graph to find the solution. Now, this simple change is totally revolutionary. It forces the AI to build a mental model, to essentially draw a map of the problem's structure before it even attempts to give you directions. It's a game changer. So, did it work? Oh boy, did it work. Look at this chart again. Those solid lines show the performance with this new technique. See that solid blue line for GPT-4? It is dramatically higher than any of the dotted lines from before. It's an absolute night and day difference. The accuracy just skyrocketed. Let's put some hard numbers on that. With a standard prompt, GPT-4's best shot at accuracy was around 65%. Okay, not bad. But with the Plan Like a Graph method, that jumped to almost 78%. That's a massive leap in its reasoning ability, just from changing how we ask the question. This is an incredible breakthrough, for sure. But, as with most things in science, the story doesn't just end there. There's a catch, and it's a pretty significant one. So while this new technique was a huge improvement, the researchers wanted to know, where does it break? What happens when the plans get really, really complex?
And here it is. This is the sobering reality. This graph shows what happens as the plans get more complicated. That's moving from left to right along the bottom. Now, look at that solid blue line for the enhanced GPT-4. Its accuracy is great on the left with the simpler tasks. But as the complexity ramps up past a certain point, performance completely falls off a cliff.
So what this tells us is that structuring the prompt is an amazing workaround, it's a powerful hack, but it doesn't fundamentally fix the engine underneath. We are still slamming into a hard ceiling when it comes to the model's core ability to handle truly complex reasoning. All right, so let's zoom out. What should we take away from all of this? It's a fantastic insight into both the incredible power and the very real limits of today's artificial intelligence. This table really just summarizes the results perfectly. The plan like a graph method gave a nice boost to every single model they tested. But just look at those numbers. It also shines a massive spotlight on the gap that still exists in raw reasoning power between a model like GPT-4 and the others.
So, what's the bottom line? Well, first, LLMs are not born planners. They don't do it naturally. Second, and this is so important, how you ask the question, the prompt, is absolutely critical. Third, forcing the AI to think like a graph can unlock some serious reasoning power. But, and this is the big one, we've also found the current ceiling. There's a point of complexity where even our best tricks start to fail.
And that leaves us with the ultimate question, doesn't it? This research shows us a brilliant path forward, but it also reveals just how far we still have to go. So the question isn't just, can an AI plan, but how do we build one that can actually handle the endless, messy, and totally unpredictable complexity of the real world?